Chalo. Vaishnavi, we started, okay na? So already, because the subject is already you have learnt. And one happy thing is, so this process engineering principle already you have learnt. Maybe a BTech students or B Pharma students in our undergraduate level. Luckily that nobody is there for MSc. That is a good sign. And because most of things you have learned from your undergraduate, but once again, we are going to have an overview of all engineering subjects. Like for example, you have studied fluid mechanics, you have studied heat transfer, you have studied mass transfer. Am I right or not?
Yes.
Pharma people also have studied unit operation 1 and 2. Pharma students.
Yes, sir.
Yes, sir.
Yes, sir.
Isn't it now?
Yes, sir.
You have studied unit operation 1 and 2. Saida?
In unit operations, the machineries, the mechanisms, and the workings.
Okay, na?
So are used for manufacturing purposes.
Yeah. So this is not a new subject for you. Hopefully, you have studied at our undergraduate level. Again, I would like to go because already we have missed some few classes. With that, I would like to start because I don't want to take much introduction. So today, basically, because unit operation, this completely we can call as a process engineering principles mean the two things are there. Here in the process engineering principle, before that, we would like to have the two definitions. This is what subject name what here? Process engineering principles. Process engineering principle. Okay, na? The principles. Why do you require process engineering principle, Vaishnavi? To study being a biotechnology students? Vaishnavi?
Yes, sir.
You tell better. And one thing is my class first, the rule is everybody has to be more proactive. They have to connect to the class. They cannot, make it na video mode off and mute and they will be away. Please, I will ask questions. Now video make it, you make it video mode off only. Whenever I'll ask that time only you make it video mode, okay na? But everybody has to connect the class. And I will ask you please, what are things I have paused the information, please you reiterate. Then we have to reiterate. Clear, Abita? With that only we can go hand in hand. Otherwise, these are online classes. People are not serious. Simply say, okay, na, they will log in and they will be somewhere. Okay, na? It is not going to be possible. Right? So here, why do you want to study the process principle, Vaishnavi?
Sir, it is like the application of the nature, application of the principles of the nature for industrial purposes.
So any industries, if you go the manufacturing sector, because nowadays you can work up to R&D level, okay, but when you go the scale up level, let us see that vaccine production. Okay, but you make it video off, madam, Vaishnavi, video off. When you go scale up level, then what is going to happen now? There, generally the production, you required engineering knowledge. Let us see that the basic engineering knowledge you are going to encounter in the production process of fluid mechanics. The fluid mechanics is a branch of engineering science. It deals with the fluid, the nature of fluid and flow of machineries, all these things. Like that, we are going to deal with the heat transfer. Because the heat transfer is once again, the branch of engineering science, it deals with the transfer of heat, different modes, the mechanism modes, and as well as the loss of heat transfer, and the heat transfer equipment, everything we are going to see that. Same thing is we are going to see in case of the movement and transfer. Same thing is in case of, that's why here the two terms we are going to discuss in case of the process principle. One is unit operation and second is unit process. Unit operation and unit process. Bhavya? Bhavya?
Yes, sir.
What do you mean unit operation?
Unit operations.
How do you define unit operation?
The operations that we use to perform in industrial, for industrial purposes.
Huh?
Hello?
Beta. What do you mean unit operation? Unit operation mean which deals with the only physical changes that called unit operation. What do you mean unit process? Uma Maheshwari? Uma Maheshwari?
Sir.
What do you mean unit process? Unit process mean which deals with the chemical changes. That is called unit process.
Okay, sir.
Okay, na? Okay, na? What is the example of unit operation? Bhavya? What is the example of unit operation? Not audible.
Unit thermoreactors or all other things. I guess.
Example of unit operation. Tarun?
Evaporation, filtration.
Why? Very good. Evaporation, filtration. That's all. Dhoni hai. See?
Separation also, sir.
Crystallization.
Polymerization. Filtration also, sir.
Right. See, which deals with the only chemical, only physical changes. Example, simple size reduction is one of the unit operation. Separation, one of the operation. See, separation. Sorry, chemical. So, here, distillation, sedimentation, flocculation. Okay, now? So, these are what here? You can consider drying, absorption, crystallization. Isn't it now? So, liquid extraction. These are all things you have studied. What's it useful? So, this is called what here? Unit operation. What is the example of unit process? Vinay Ranjan.
Hello, sir.
What is the example of unit process?
Hello. Am I audible?
Hello?
Sorry. Hello.
Tell me, audible only. Unit process.
It's like chemical nitrations or oxidation types.
Oxidation, reduction reaction,
Yes.
fluorination. Okay, na? So,
Yes, sir.
any reaction will come under
Process.
unit process. Right. Actually, if you see the start with we are going to apply the most of the engineering principle as a chemical engineer applies engineering principles, civil engineer is going to apply engineering principles, electrical engineering also apply principles, but seeing biotechnology also we are going to apply engineering principles. So, when you go the process engineer in industries, process engineer in industries, process engineer. Okay, now. But he's going to concern the transportation of liquid. Transportation of fluid. So that fluid what here? It may be a liquid, liquids and gases. Through please everybody has to note down. I will ask you, please, you have to read it that time. Okay, now through a piping and all kinds of process equipments. Process equipment. Nare cheppama. Good afternoon. Class lo cheppavachuna. Right. What I said here, the first point is when the process engineer enter in the biotech industries or pharma industries or biopharma industries, he is going to deal with the what here? The transportation of fluids, either liquid or gases, through a piping all kind of process equipment. What are all kind of? Heat exchanger, distillation column, boiler, condenser, okay, now evaporator, all these things. For that, what is going to required? It is going to require what here? The required is what here? Being engineer, the process engineer requires estimation of, the first thing is, okay, na? Estimation of delta P in a system. And second thing is power required for pumping. Power required for pumping. What I said, beta? Vaishnavi, can you reiterate?
Yes, sir.
Tell me.
For process engineering, there are two things that are required. One is estimation of delta P in a system.
What do you mean
and
delta P?
power required.
What do you mean delta P?
Power. I mean.
What is basic driving force for the fluid flow? Kusuma?
Sir,
What is the basic driving force for the fluid flow?
driving force?
For the fluid flow?
Don't know.
What is the background, Kusuma?
BTech Biotechnology, sir.
My God, where you did BTech Biotechnology?
Koner Lakshmi University.
Better than you should say better. What is the basic driving force for the fluid flow?
Viscosity of the energy
Unit
required.
Unit mass by energy.
Bhavya?
Hello, sir.
What is the basic driving force for the fluid flow? Anybody from CBIT?
It's pressure difference.
Who is given better CBIT? I'm asking a question.
Yes, sir.
Who has done
Pressure
graduation?
difference.
What is the name, please, beta?
Sir?
Name. Can you just spell out your
Naseem.
name?
Naseem. Yes, sir.
Naseem, tell me what is the basic driving for the fluid flow?
It's change in pressure.
What is the basic driving force for the heat flow?
Sir?
What is the basic driving force for the heat flow?
Heat.
Yeah, beta. Naseem.
Yes, sir. Wait. One second.
Temperature, sir.
Yeah, temperature gradient. What is the basic driving force for the mass transfer?
Weight.
What is the basic driving force for the mass transfer? Concentration gradient.
Oh, okay.
Right? Hello?
Sir.
What did I say, beta? Can you reiterate once again? Asim.
Yes, sir.
What did I say here? What is the basic driving for the fluid flow? What is the basic driving for the heat flow? What is the basic mass flow?
Yes, sir. Basic driving force for fluid flow is pressure difference. For heat flow, it's a temperature gradient. And for mass is a concentration gradient.
Very good. These are very fundamental concepts, beta. Tomorrow, anywhere you are going to face interviews or viva voce, they will ask such type of questions. Now, my thing is, a process engineer, my point is now, a process engineer, when he go in industries, first of all, he has to have idea. What are the idea he has to have? when he is going to deal with the fluid, the transportation of fluids. Now we are going to start with the fluid. Hello, in an engineer, he is going to see in terms of understanding fluids. Next chapter, we are going to see understanding of the heat. Next chapter, we are going to see understanding of the mass. This is and unit operation. Entire four the four dimensions are there in the process engineering principle. One is you have to understand the unit operation. Second thing, you have to understand the fluid flow behavior. Third thing is you have to understand the heat transfer concept. Fourth thing is you have to understand the mass transfer concept. क्या बोला बेटा मैं? Hello, Azim, tell beta, what did I say? Hello.
Yes, sir.
बताओ बेटा मैं क्या क्या बताया?
Sir, I didn't listen. Hello.
Vaishnavi?
Yes, sir.
What did I say beta?
To understand the unit operation of fluid.
Please, all of you, once again, my class, online class has to effectively mean you have to listen carefully, first thing is. And you have to write it down, things, notes properly and very quickly also. With that, we can go hand in hand. Otherwise, if there is gap, then obviously things cannot move fast. It's going to be dead time. It should not be much time should be happen between teacher and students. Obviously you have to be more attentive, more the connected things. Then you can write the things and followed by you can listen thing and understand quickly and please you have to reiterate. Then only we can go fast. Isn't it now?
Shall I?
Hello?
Yes, sir. Yes, sir.
Right, beta. And you have to be respond also, please. I told, if you are more proactive, more responsive, then obviously things will go very properly. Maheshwari.
Yes, sir.
Maheshwari. Followed up
Yes,
what
sir.
I said? Right. So now what I would like to say here, under process engineering principles, we are going to understand the subjects 4-dimensional way. First thing is, what is the unit operation you have to understand. Second is, what is the fluid for behavior you have to understand in terms of point of fluid behavior point of view. Third thing is, what is the heat transfer mechanism, what is the heat transfer flow, what are the methods, what are the laws, all these things you have to understand. And the fourth thing is, what are the mass transfer, what are the mass transfer equipment, all these you have to understand. Clear now? In that first point of view, I'm going to start. I would like to leave the unit operation, but I would like to go second part. That is a fluid flow. The behavior of fluid flow. For that, a process engineer, when he enter the industries, in terms of the fluid mechanics point of view, as a civil engineer also will understand his application point of view, mechanical engineer also will understand his point of view, electrical engineer also, chemical engineer also. But we are a biotechnologist. When he's enter in industries, so with respect to the fluid flow, what the transportation of fluids mean what here? The liquid or gases. So this liquid or gas is going to transport through, one is piping, second is the process equipments. I told distillation column, boiler, chiller, compressor, evaporator, all these things. And for that, what is going to require an engineer in terms of fluid mechanics point of view? First is he has to estimate the delta P in a system. With that, what is going to get idea? Roshna?
Yes, sir.
Why do you want to measure the delta P in a system?
To know the flow of the fluid or gas, liquid or gases, sir.
Yeah, by that, what you are going to understand?
The process engineering principles, how we can...
Nahi beta, Roshna. If delta P is positive, then what is going to here? Do you require any external energy to transport the fluid from one point to another point?
No, sir.
If minus delta P, then what is going to require?
We need the energy, sir. We need the energy.
We are going, please somebody, kids, now. Here, minus delta P. Minus delta P mean what here? A negative pressure gradient. Mean requires some extra energy like pumping. So pumps also required, isn't it? No? So for that, so second point is what here? We have to understand, estimate the power required for pumping, whether we required or not. That is 2 points I tell you. Now? Next, third point I would like to move. Clear are these 2 points?
Yes, sir.
All of you please respond. Now? Right. Please, if you are not going to follow, please you stop me, ask question. Okay, get clarification. Otherwise, you should not. Okay, na? I will ask question everybody. Not only Vaishnavi, not only Roshna. Okay, na? Right. So third thing is what here? For that, he has to select selection of a suitable type of pumping devices. Suitable type of pumping device. Okay, now? And fourth thing is what here? He has to measurement of the flow rate also. He has to select a suitable type of flow measurement devices. Okay, selection of suitable flow measurement devices. Okay, now device. What are flow measurement device? Tarun, have you come across? Tarun.
Hello.
What are the pumping devices? Can you list out? In terms of the fluid mechanics point, what are the pumping devices you have come across? Tarun. Akanksha? Akanksha? Hello?
Yes, sir.
Tell beta.
Orifice meter.
Very good. Orifice meter, venturi meter, rotometer, pitot tube. Yeah, these are what here? Suitable. What beta these are?
Pumping devices.
Not pumping device beta. Somebody beta. Akanksha.
Yes, sir.
Somebody is there back of you, huh?
No, sir.
Right.
Bye.
Akanksha. Huh?
Goodbye, Tatra Bhajan. Look at the things, bye. Where? Hello. Okay.
Akanksha.
Yes, sir.
What you said beta?
Orifice
Student
meter,
power लिख देंगे
venturi meter.
power ले देंगे
Saida. Saida.
yes sir
Saida.
yes sir yes sir
बेटा
Yourself.
मैं सवाल पूछ रहा हूँ. Somebody okay making noise back of you.
sorry
Please,
sorry
beta, you
sir.
request them.
sorry
Akanksha. So the flow measure, what you said that is a flow measurement devices. Venturi meter, orifice meter, rotometer,
Orifice meter.
pitot tube. Yeah. What are the pumping devices? Saida. Saida.
yes sir
What are the pumping devices in fluid flow mechanics?
I didn't have any idea about it
क्या बेटा before क्या ना?
sir
So there is a
Vaishnavi?
40-minute time limit, so the class might end any moment. Can you, be able to reach on again?
Centrifugal pump.
Who has given answer?
Akanksha.
Akanksha. So we have centrifugal pump, we have piston pump, we have plunger pump, we have reciprocating pumps. Okay, na? So many types of pumps used to be there. Two pumping. Okay. Now, a mat is going to exist a two state. One is a solid state, third is fluid state. A matter is going to be exist either solid state, okay na, or fluid state. This fluid state, once again, what you can able to see? Liquid or gases and vapors. And vapor. vapor. Okay. Now we are going to see basically the behavior of solids, structural behavior of the solid, liquid, and gases. Please, everybody has to remember. Okay, just listen properly. I will tell you here how the structurally is going to have the difference between the solid, liquid. Already I have studied from the the high school standard onwards. Okay, now so solids out here, the molecules are. The మన స్టేట్మెంట్ మన ఫాదర్ ఓకే ఓట్ ఆఫ్ థ్యాంక్స్ కూడా అది టెంప్లెట్ ఉంటే బాగుంటుంది మనం ప్రిపేర్ ఇష్టాన్ని పిలిస్తే బాగుంటుంది ఒకసారి కామాక్షి సార్ ఫస్ట్ ప్లీజ్ వెయిట్ సమ్ టైమ్ ప్రొఫెసర్ కామాక్షి సార్ నెక్స్ట్ ప్రొఫెసర్ తారా కళ్యాణి అది ఉంటుంది డైరీ ఉంటుంది బుక్ ఉంటుంది కదా నీకు సీనియర్ ప్రోగ్రామ్ బుక్ ఉంది కదా డైరీ దాంట్లో నీరు ఒకటి ఆడద్దు చంద్రమోహన్ పల్లి నీరు చేయడం నీరు లాస్ట్ నీరు ఉంటుంది అంతే క్రాంతి సార్ తర్వాత నీరు తర్వాత సార్ నువ్వు దాంట్లో ఉంటుంది లిస్ట్ సేమ్ అదే లిస్ట్ ప్రకారం పెట్టేసి అందరి స్లెప్ ఉంటుంది సి అంతే ఓట్ ఆఫ్ సెన్స్ టెంప్లెట్ ఉంటే మనకు కొంచెం నీట్ సో గుడ్ ఈవినింగ్ సరే ఆల్ control of examination of the respected autonomous colleges. Right. A matter exists either a solid state or fluid state. So the liquid and gases, okay, we are going to see in case of fluid. But here, the structurally how is going to be different, I will say the 3 point of view. The solids, the molecules, if you see the molecules are very closed form. The liquid what here? The spacing between the molecules the relatively large compared to the solids. The gases what here? The spacing between the molecules, the gaseous molecules are still larger compared to the liquid and as well as solids. That is one point of view what behavior you could be able to observe. Please listen carefully. 305 you will change your name, but first your name. Next followed by here in a given volume, if you consider the solid and liquid gases how is to be there. In a given volume, what here? Solid contain a large number of molecules. In a given volume, a liquid contain a less number of molecules compared to solids. And as well as in a given volume, if you observe that a gases still is going to contain much less number of molecules compared to liquid and as well as solids. That is second way of the structural behavior you're going to see liquid, solid, gases. That is normally way of what you observed. I would like to recap. Next is third observation what you could be able to see solid, liquid, gases. The force of attraction between the solid molecule is larger. And in case of the liquid, the force of attraction between the molecules, the liquid molecules are relatively less compared to solids. Next, if you see after the gases, the force of attraction between the gaseous molecules are still less compared to liquid and as a solids. This is a 3 behavior what we observed, the structurally how the solid, liquid, gas is together before studying the fluid mechanics subjects. Please, Vaishnavi, can you reiterate?
Yes, sir. The molecules in solids are closely packed, and in liquids the space is a little larger, and for gases the spaces between the molecules are even larger than liquids. In solids, the force of attraction is large, and in liquids, the force
between
of
the molecules are large. You say that.
Molecules. Force of attraction of the molecules are relatively less than solids, and in liquids, the force of attraction of molecules is lesser than solids and liquids.
Gases in case of gas. Okay. Next, other point of view. Third thing. In a given volume. In a given volume, the solid contain large number of molecules, And liquid contain less number of molecule compared to solid, and gases contain still less number of molecule compared to
both in solids and gas.
solid and liquid. Clear at this point? Hello?
Yes, sir.
Nazim? Nasim?
Yes, sir. Yes, sir.
Right, beta. Now, here we are going to discuss the branch of, what do you mean fluid mechanics? That we are going to see, the definition of fluid mechanics. Okay, now? The definition of fluid mechanics is definition of fluid mechanics. Fluid mechanics. It is a branch of engineering science. It's a branch of engineering science. It deals with study of fluid at rest. Okay, na? At rest or at motion is called as fluid mechanics. What, beta? Kusuma, what I said?
Yes, sir.
It is a branch of engineering science which deals with the study of fluid at rest or motion is called fluid mechanics.
Very good. Now we are going to define hydraulics. Anybody hydraulics can define, beta? The study of water is called hydraulics. Kya beta? Hydraulics. Please, everybody has to note down. At the end of class, I will say that please you have to summarize. You have to reiterate within 5 minutes that you have to do. For that only I will give the assignment 5 marks. Those students will perform. For that I will give 5 marks. Other I will give 0 marks. Okay, na? At the end of semester, you have the 5 marks assignment. Do you know? Do you have idea? This is 25 marks is the internal marks. 5 marks is the assignment marks. Okay. What do you mean hydraulics, beta? The study of
water.
The study of water referred as hydraulics. Water. Okay, na? Referred as hydraulics. Right. Next, the fluid mechanics, we are going to classify 2 types. Fluid mechanics, we are going to classify the 2 types. How do you classify, beta? Bhagya? Bhagya? Sir, not Bhagya. Bhavya? Bhavya? Fluid statics. Fluid dynamic. Okay, na? Dynamics. Fluid statics and fluid dynamics. Followed on? Azim?
Yes, sir.
But what do you mean fluid statics here?
Fluid at stationary.
Yeah. It deals with the study of fluid at rest, which involve the study of pressure exerted by fluid at rest condition. Second thing, what here? The variation of fluid pressure throughout the fluid mass. There are 2 things is going to be studied in case of fluid statics. What I said, beta? Vaishnavi, fluid statics mean what here? It deals with the study of fluid at rest, which involves the study of pressure exerted by fluid at rest condition. Second thing, what here? The variation of fluid pressure throughout the fluid mass. Okay, that we are going to see the. Okay, now yes, the fluid statics deals what? The study of fluid rest. Okay, now study of fluid at rest, which involves study of
Pressure exerted by fluid.
Pressure exerted by
Fluid at rest.
fluid mass at rest.
Fluid mass.
At rest. Second thing what here? Variation of fluid pressure. Variation of fluid pressure throughout the mass. Throughout the mass. That's the fluid statics. So next what here? What beta? Bhavya. Bhavya Saidi.
Sir.
हाँ बेटा Velgapudi.
हाँ sir.
Beta. Now what? That Velgapudi is Amaravati headquarters, na?
No, sir.
No.
Not yet decided. Not yet decided, sir.
Not yet decided, huh? So your Velgapudi is your name, surname, and that place also Velgapudi, na?
No, sir. Guntur, sir.
No, Guntur, Velgapudi one place is there, na?
Velagapudi place is there, but my hometown is Guntur.
No, I'm asking. Velgapudi is the place, na? In Amaravati
Yes, sir,
part,
yes.
one of the place, na? In
Yeah,
Amaravati?
one of the part. Yes, yes, sir.
Yeah. So your name, your surname is powerful. What I said, beta?
Fluid statics, sir. Study of fluids at rest, which involves the study of pressure exerted by the fluid mass at rest and variation of fluid pressure throughout the mass.
Throughout the mass means, see, if you have taken, we have taken the 10 kg of fluid mass, leda. Right. Okay, na? So that is what beta Saidi? So that is called the fluid statics. Fluid dynamics, what beta? Fluid dynamics mean?
Study of fluid in motion.
Very good. Study of fluid in motion. Saidi.
Sir, sir.
Study of fluid in motion. Study of
fluid in motion.
Shall I array? Already you have taken these points.
Yes, sir.
Please, everybody has to note it down. I told also. Fluid dynamics mean?
Study of fluid in motion.
Yeah. Fluid dynamics. Study of fluid in motion. With respect to? Okay, na? Okay, na?
The viscosity and the mass.
No. With relative to stationary wall and boundary wall. Stationary wall or boundary wall. Fluid dynamics, what is study of fluid in motion with relative to stationary wall and dynamic. Okay. Stationary wall or boundary wall. That's called fluid statics. Okay, na? Please just Vaishnavi, can you just reiterate what point I have covered till now? Fast. Next, I'll go next point. Vaishnavi.
Yes, sir. You told about fluid mechanics. So in fluid statics, it is a study of
definition of fluid mechanics. Definition of fluid mechanics.
It is a branch of engineering science that deals with study of fluid at rest or at any motion. So you've also told about hydraulics. It is a study of water. It is a study of water. And, in fluid mechanics, we have fluid statics and fluid dynamics. So fluid statics is the study of fluid at rest, which involves study of fluid pressure exerted by fluid mass at rest.
Hello, 1 minute. Namaskar, Pullaya garu undra section lo. అది 4 o'clock మన డి గారు కేక్ కటింగ్ ఉంది బర్త్డేది. ఒకసారి మీరు డి ఛాంబర్కి వచ్చేయండి 4 o'clock. ఓకేనా? అవునండి. ఇంకెవరు లేరు మన వాళ్ళు అంతే కదా? యారు మేడం అంతే కదా? Vinay Ranjan, where are you? I'm driving,
No, sir.
Vaishnavi, please, beta.
Yes, sir.
Go ahead, next.
And fluid dynamics is a study of fluid in motion with respect to stationary wall or boundary.
Okay. It's
it
related
is
to or
variation of fluid pressure throughout the mass.
Right. Next, beta. Definition of fluid. First, we are going to do definition of fluid. Okay, na? So, definition of fluid. Okay, I will give definition, but please everybody has to note down. Fluid is a substance which is capable flowing if allowed to do. The first way of definition. Second way definition, fluid is a substance that has no definite shape, its own, but it can gain shape with the help of a container or vessel. Third is fluid is a substance when it's subjected to shear force undergoes continuous deformation as long as shear forces exist. That is the 3 way of definition of fluid. बताओ बेटा और एक बार आजिम.
Yes, sir. You repeat it once again.
Sir, can you repeat it?
Fluid. What बेटा मैं क्या बोला? Fluid substance which okay na, which is capable flowing if allowed to do. If allowed to do. That is the first way of definition. Second is fluid substance. Fluid is a substance. Okay, na? That has no shape. That has no shape of its own. It can gain shape with help of container or vessel. Third is what here? Fluid is a substance when subjected to shear stress. It can undergo continuous deformation. क्या बोला बेटा मैं? Velgaputi.
Sir.
बताओ बेटा. You tell बेटा.
Yeah.
What I said?
Fluid is a definition of fluids. So definition of fluids is defined in 3 ways. So fluid is a substance capable of flowing if allowed to do. And the second one is fluid is a substance that has no shape of its own. It can gain shape with the help of container or vessel. Third one is fluid is a substance when subjected to shear stress, it can undergo continuous deformation.
Until
continuous deformation.
As long as the forces exist are okay na. So how long the force is going to exist, it will go continuous deformation, right?
Okay, sir.
Right. So that is the definition of fluid. Tarun, well done.
Yes, sir.
Right, beta. Now we are going to classify the 2 types of fluids. Bhavya?
Sir.
Beta, you can classify
sir.
The persons also you can classify 2 types of persons. Which type of person? Tell me.
Sir?
You can classify the persons also, na? The 2 types. In general.
According to gender, we can classify persons as male and female.
Gender classification. Very good. Next. Any other way?
Any other way?
According to the age.
So we can classify the persons also now. Bhavya, a good person, bad person.
Yeah.
Who is good, who is bad, Bhavya?
So whatever we think, sir. If we think good about the person is good.
Yeah, which you like. If okay, it has the quality, then you can think good person. If you don't like that quality, then you say bad person. That quality somebody like it also. That's a related term.
Yes.
Okay, isn't it?
Yes. Yes, sir.
Right. So we are going to classify here the fleets are the two types of fleets. Good fleet, bad fleet. Bhavya,
Sir.
how you are going to classify fleets in general?
In general, fluids which flow very like by the depending on their flow, how they flow.
Fluid, we are going to classify two types of fluid. One is ideal fluid. Second is the real fluid. Okay, what do you mean ideal fluid? I will say that Bhavya is the ideal girl. Ideal hota hai beta? Good girl. Ideal mean, please remember the statements. Which does not offer resistance to flow, deformation, change of shape. It should not offer. That is the first point. Second point, it has no viscosity. Third point, it's a frictionless. Third is it's incompressible. That fluid is called ideal fluid. The real fluid, what here? Quite opposite. Which fluid offer a resistance to flow, deformation, change of shape, or okay na? To flow or deformation to change of shape. And it has viscosity. And it is a frictional fluid. And it is compressible fluid. That is the definition of ideal fluid and non-ideal fluid. Clear, beta? Vinay?
Yes, sir. So can you
What
repeat
I said,
the first point? Can you repeat the first point?
Who is beta asking?
I'm Vaishnavi, sir.
Vaishnavi, right. Which does not offer resistance to flow, okay na?
Yes, sir.
Comma, deformation. I can say R beta. To flow, deformation, R, to flow, deformation, or change of shape. That is the first property. Second word here, it has no viscosity. Third is what here? It is a frictionless. It is frictionless. Fourth what here? Incompressible. It is incompressible. This is quite opposite. Okay, now what? Which has one. Which okay now does not which does not which offer resistance to flow or deformation or change of shape. Tell me, Vaishnavi, what second point should have real fluid?
It has
Vaishnavi,
friction.
it should have
Friction.
viscosity, beta. I have written point left. Third thing what here?
Friction and it is
a frictional fluid. And it is a compressible fluid. That is called a real fluid. Clear? Hello, Bhavya.
Sir, yes, sir, clear, sir.
What about the difference between ideal fluid and non-ideal fluid? Tell.
Sir, ideal fluid which does not offer resistance to flow or deformation or change of shape. it has no viscosity, and it is frictionless. It is incompressible also. Real fluids, which offers resistance to flow, deformation or change of shape. It has viscosity.
Sorry, sorry, right. Adi under share chesukovali, right. Cheppama.
Yes, sir. Real fluids have viscosity. They are frictional fluids and are compressible fluids also.
Right. Example of ideal fluid. Bhavya?
Yes, sir.
Example of ideal fluid.
1 second.
What is the example, beta? All imaginary fluids are ideal fluid. Example of non-ideal fluid are real fluids, which is a natural occurring fluids are real fluids. Hello?
Yes, sir.
क्या बोला बेटा मैं? What is it?
All imaginary fluids, sir.
Are ideal fluid. All natural occurring fluids are
real fluids.
Real fluids. Clear?
So this classification is based on which factor, sir?
Madam.
So the classification. Sorry.
Sorry. Okay, no problem. ఓకే ఒకసారి మేడం మీరు కూడా చెప్పండి. నేను చెప్పేశాను, కొంచెం మీరు కూడా చెప్తే బాగుంటుంది. నేను చెప్పేశాను. ఒక్కసారి నేను క్లాస్ ఉన్నా మేడం, క్లాస్ అయిపోయి వచ్చేస్తాను నేను. మీరు ఒక్కసారి కోఆర్డినేట్ చేయాలి, వచ్చేస్తాను నేను. ఓకేనా? అంటేమ్మా రియల్ ఫీల్డ్ ఆర్ట్ what is who is Vaishnavi? Saida asking question.
So yes, sir. This classification is based on which factors? The classification of fluid based on
what factors I said, Vaishnavi, till now? Bhavya?
These 4 factors only, sir.
Definitions.
Yeah. Viscosity, yeah.
बेटा उसको जवाब भी मालूम है, सवाल भी मालूम है, फिर सवाल पूछो.
नहीं सर, कुछ और फैक्टर है क्या पूछ रहा था सर?
नहीं तो बड़ा फैक्टर तो देखो, हाइट, वाइट, कॉम्प्लेक्स पूरा बोलते थे ना. अरे लोग का क्या, गोरा लोग, काला लोग, छोटा लोग, बड़ा लोग, कुछ वो तो प्रॉपर्टी ना, कैरेक्टरिस्टिक है ना. इधर भी है. But it should not offer resistance to flow, change of, okay ना. और किस लोग को बोलते हैं माइल्ड लोग है, बहुत सीधा साधा लोग है. कॉम्प्लेक्स लोग किस लोग को बोलते हैं? साइदा?
कॉम्प्लेक्स.
नहीं, बंदा सीधा साधा बंदा बोलता है. What is the difference between सीधा साधा and as well as a complex?
Complex don't know sir. Simple is simple living.
अरे सिंपल बोलते देखो बेटा, चलो मूवी के जाएंगे, कुछ क्या दोस्त बोलते चलो, नहीं कुछ लोग क्या मानो, नहीं will take time. Own classmates also, okay na. Bhaiya will say that, okay, Saida will ask, okay na. Bhaiya will say no, I will, okay, give some time for me. Then okay na. Vaishnavi will say, chalo, kya sochne ke liye. So that is also classification of simple and complex person. Right. So now we are going to classify the fluids is other way. This I am giving example. I am just okay na, dragging other dimension for you. The classification of fluid, the 2 types of, one is compressible fluid and second is incompressible fluid. चलो बेटा, behavior अब बोला ना, चलो मूवी के जाने के साइदा बेटा. कुछ लोग अप्रोपोज बोलते हैं भैया को and वैष्णवी को, कुछ लोग okay, you are going to propose this, okay, one idea to them, so shall you go movie tomorrow? Then भैया will say नहीं मेरे मम्मी पापा अभी कोविड पूरा नाम चल रहा है, फिर कोविड 10 चल रहा है, फिर क्या थिएटर क्या, okay, they are following COVID नाम से, no, I will take time and I will take it and I will tell, okay na, give for me 2 days. Vaishnavi will say that, okay, you know, government has given guidelines, okay, we can go. So who is Sida, who is complex?
Vaishnavi is simple. She is complex, she will take factors, other things.
Yeah, complex means what? Thought process, more thought process you want to put. Okay na?
Okay, yes sir.
Right, chalo beta. So now we are going to the behavior. I have given example of behavior here. Simple. Same thing is the fluid of some behavior beta.
Yes.
Hello, Vaishnavi?
Yes.
Fluid of some behavior. But based on behavior also we are going to classify the 2 types of fluid. One is the compressible fluid, second is Second is incompressible fluid. Okay, now we are going to classify the classification of fluids. But I am giving meaningful examples or irrelevant examples
Meaningful, sir.
Or the okay, now related example, right? So the classification of fluid based on sir. అన్ని సార్ మీకు క్లీనింగ్ అన్ని చేస్తున్నాను. సో అన్ని చేయించేశాను. యాజ్ వెల్ యాజ్ మన కొన్ని అది మన బ్యాటరీ లేదు, అది బ్యాటరీ కూడా రెడీ చేయించాను. సో మన సతీష్కి నేను అవి ఇచ్చేసాను, వాటర్ బాటిల్ అన్ని ఆయన టీ కాఫీ తీసుకుంటాడు. అక్కడ 7 o'clock పైన లైట్స్ కూడా ఇచ్చాను సార్. మన సెకండ్ ఫ్లోర్ లో డిన్నర్. అవును సార్, అవును సార్. అడుగుదాం సార్. అది మొన్న ఎప్పుడు ఇచ్చారు సార్ నాకు ఇది మ్యాగ్నెటీ వాళ్ళు? నేను ఇక్కడ సరే ఓకే సార్, ఒక్కసారి చూస్తాను సార్. సరే ఈ క్లాస్ అయిపోతుంది, క్లాస్ కానీ వచ్చేస్తాను కాలికి. రైట్. Based on behavior of the fluids, we are going to classify based on behavior of fluids. Based on behavior of fluid, we are going to classify. Okay now. So the two types of fluid. Arey yaar kya ho gaya? What type of fluid beta? Saida?
Compressible fluid and incompressible fluid.
Chalo beta, very good. Compressible fluid. So I'm very happy. This batch is very good batch. Why very good batch, Vaishnavi?
Interacting with the teachers in class.
Very good, interact with the teacher. So if you have the more interaction, more knowledge exchange will be there. You're all a master students, already have learned a lot of things in our undergraduates. So sometimes I may get chance to learn from you also. क्या बेटा ये पूरा कलरफुल आ रहा है? Right. Hello. Two types of fluids. One is compressible fluid. क्या resound आ रहा है बेटा? Hello?
No sir.
No sir.
Second is incompressible fluid. Okay. So here the behavior, when behavior under the action of externally applied. Beta, dekho. Hello?
Yes sir.
Yes sir.
Vaishnavi, if Vaishnavi relations with Saida is good, then she will give positive, okay, response. And okay, quick response. If somebody sometimes, okay, long back she has given a bad experience now, then she also will give same na, according to Newton third law. Isn't it, beta? Hello?
Yes sir.
Yes sir.
So here, under the action of externally applied temperature pressure, we are going to classify compressible fluid and incompressible fluid. Start beta. Which fluid density is affected appreciably with moderate change of temperature pressure that called as compressible fluid? Incompressible fluid. Which fluid density is insensitive with respect to moderate change of temperature and pressure? That fluid is called incompressible fluid. Once again, I will repeat, please. I will ask you, you have to reiterate. The compressible fluid means which fluid density is sensitive with respect to a moderate change of temperature and pressure. That fluid is called compressible fluid. Incompressible fluid, what here? Which fluid density is insensitive with respect to a moderate change of temperature pressure. That's called incompressible fluid. Tarun, please reiterate, beta.
Sir.
I reiterate what I said. The definition of compressible fluid, incompressible fluid.
Compressible fluid, which fluid density is sensitive with respect to moderate
change of what? Moderate change of temperature and pressure.
Moderate change of temperature and pressure.
Incompressible fluid? Bhavya.
Sir, the fluid density, which fluid density is insensitive with the moderate change of temperature and pressure is called incompressible fluid.
Very good. उसके लिए लोग बोलता है बेटा बेटी बचाओ बेटी पढ़ाओ. सही नहीं बेटा?
Yes, sir.
See, that's very important. If you have interest, then you will get more connect. If you don't have interest, then obviously connect also weak. Signals also weak signals used to be there, no? Between the source and receiver.
Yes.
Chalo. So write the definition of compressible fluid. Compressible, okay, na? The compressible fluid density, what? Okay, which fluid? Which fluid density is sensitive with a moderate change of temperature and pressure. This is what, beta? Which fluid density is insensitive with a moderate change of temperature and pressure. मेरे को एक सवाल होता है Saida.
Yes, sir.
Sir always ask question girls only. Sir won't ask question boys. Because question asking girls, see the signals, okay now? See, if you have the strong signals, then the current will flow very fast and quickly. If you have weak signals, what? The time will take more time now.
So what you are explaining, we get it or not, you are asking that. What you are explaining the chapter, we are getting it not, that's the reason you are asking it.
Yeah. One thing is, so then only meaningful. Otherwise, Suresh.
Yes.